Good morning, friends. Let's discuss about the filter transformation. So map, filter, flat map, all these are like very much basics of functional programming, whether it's Java or whether it's Spark. So in this filter function, it returns a new data set formed by selecting those elements of the source on which function returns true. So it is like once we suppose we are mapping or flat map and we transform one object into another object, and after that we want to filter those objects based on some criteria which returns true, then we can just have a subset of the original mapped objects, and for that we use this filter function. So as RDDs are immutable, after applying the filter transformations, new RDD is created. Okay, so again, this is very much similar to map function. This is a narrow transformation, which means that it's not involves other partitions. So one partition is mapped and the same can be filtered in the same partition. We don't need to involve the other partitions for an RDD. That's why it is called as narrow transformation. So let's write some code to understand it more. So in the previous test case, when we were discussing about the flat map, so what we were doing is that we were reading this magnacart.txt file, and we are trying to break it down into individual words. So this is file that we did in our previous video, where we broke down the whole file into individual words. For example, the text of Magna Carta, and then we had this space as well, which was tokenized, and then we had like other words. And when we ran this test case, so this was the output. We could see that we were able to break this using the flat map. So this was the flat map that we used, this one, and in which we were splitting this line into like using a regex, but whatever space is there, converting into a list. And then because flat map requires iterable, that's why we are giving it the iterator. And this is the final words, which was an RDD of all the words which were there in that file. And then we printed first few words, and we found that the text of Magna Carta was there. And besides that, there was a space also there. Here in this file, we see that there's a space here. So this space was also taken. Similarly, once we again, just to tokenize all this paragraph, after that, we have this new line character that is not taken. But again, there's a space there. This space would be also taken there. So suppose by using this filter, we want to remove all those spaces, remove all those words which are empty, which are having just spaces or other new line characters. In that case, in this scenario, we can use filter. So let's write that unit test to understand it better. So I've already got this filters test class, in which we have got this test filter in Spark RDD. Let's write that test case where we will filter all those empty words. Now, to save some time, I will copy the previous test case, at least until the flat maps. So let me copy this from here let me copy the whole thing, and then I will remove whatever I want to remove, and then add the filter method on below of it. Let's copy this, Control C, and let's go here and let's do Control V. Let's make some changes now. So let's set the app name to the filters test class. Copy this and paste it here. And now we already discussed about the map line, the difference between the map lines and the flat map in our previous video. So let's not do that again and remove it. I'll remove this and only have this flat map. Now this flat map is, again, we are revising it that it's splitting it on each of the words and creating a list of iterator of the list for each line. And then when we do the flat map, it will flatten the and then have each individual word created as a Java RDD. And that's why we were able to we were able to print the first few words, the first 10 lines using the take method here. Now let's add our filter method here. So let's trim out all those words which are null or which are empty. So I will create final var filteredWords. And then I will take the original words which we got here using the flat map. So here we got these words. So we are just going to let's make it another line, words.filter now. Filter we will use. So this is different than the filter used in Java. This is actually from the Java RDD. So we are calling the filter method from Java RDD. And here inside this filter, we want to filter out all the words which are either null or the length is less than 0. So I will do a word not equal to null. We only need words which are not equal to null, right? So this is the first condition. And word.trim dot length is greater than 0. Okay. Let's close this. So by using this filter, now we are able to filter out only those words which are not null and which are the length is greater than 0. So in that case, we will remove or discard everything which are like empty, like the empty lines that we have found before with the flat map. This all would be removed. Okay, so let's go back to our unit test case. We got this Control-Alt-L format, and now we can again call the same first few words. Or before that, we can also, after removing this, we have already printing the words count here. So let's see that what's the word count after we have filtered. We expect that it should be less than this words. Okay, so the number of words after filtering. After filtering would be filteredWords.count. And we can also assert here, assert true that filtered words would be definitely less than, dot count should be less than words.count. Alt enter to import it. That's it. Yeah, because we are filtering and we have already seen that there are a lot of words which are not greater than 0. So those will be trimmed. So that's why after filtering it, it should be definitely less than the words.count from the original word map. And then we will print the first few words. I will take from filtered words. Okay. And we expect that using that, it should not be including this space here, which we got from the previous flat map test case. Okay, so let's revise what we have done. So it's very much similar to the previous flat map test case, where we are trying to tokenize all this, just extract all the words from this file by creating first RDD first, and then after just tokenize it using flat map. But using that flat map, we will also see that we have all these empty lines also included in that words. So this is what we want to remove using the filter method. And that's what we are doing. First of all, it's exactly same as the previous test case that we are doing a flat map. And using this flat map, we are able to tokenize all the words in this file into like one individual words and stored in this Java RDD string. And now using filtered words now, we actually call this filter method on the Java RDD on this words. And here we filter out everything which is not equal to null and the length is not greater than 0. So we only take, so here it should be true means that everything should be included, which is true here. So whatever words are not equal to null and greater than 0, only those are included and everything else is discarded. So it means that all the empty lines would be discarded. And then we actually print the words count here and the filter words count. And we assert that it should be always true, because after filtering, of course, the numbers would be decreasing. We'll be discarding all those empty length words. And that's why this filter words count would be always less than words.count. And then we will first few words to assert that the first 10 words doesn't include this blank space, which means that the text of Magna Carta, and then it would be not followed by this empty line. It would be immediately by John this. Now let's run this test case to assert that whatever our understanding is correct that we just discussed. Okay, so let me run this. It's running now. Let's wait for it to complete. Okay. Yeah, so it has run now. Let's see. So total lines in the file is 1453, which we already discussed before. Now total number of words in file is 14629. and total number of words after filtering is 14416. So from 6 to 9, it moved to 416. That's what we have filtered, all those empty words or empty lines. And now it's actually evident when we first few words, not few words, but 10 words. So the text of Magna Carta, and now there is no space here in between. So it has discarded. The filter is working correctly. It doesn't include the space here. And then it is immediately followed by this. So we got first 10 words without any space, or the length, which has got 0. So guys, this was all about chapter 7. We discussed about map, flat map, and filter in chapter 7. And in the next video, we will see Spark RDD printing elements. Because printing elements is again a different concept, because we are not printing just on each of the executor nodes, on the worker nodes, but we have to think of some way that how we can even print at the driver node. Because every time we don't have all the elements in the driver node, which are being worked on by the worker nodes. So see, we'll discuss all these details in the next chapter 8, printing elements. So see you all in the next video.